All right, everyone. We're going to be working from these same notebooks that Paul was just using for teaching. We're just going to be working in a different one. So I am going to share my screen. Let's see. Okay, so you should be able to see my list of files on ChemCompute. We were just in the introduction notebook, and now we're going to be moving on to the file parsing notebook. So can everyone, so Paul or someone, can you let me know if that's what you see?
Yes. Yep.
Okay. Excellent. Okay, so I'll make a few comments about Python. So in this workshop, we're working on learning the Python programming language. And it's really in a 4-hour workshop, all we're going to be able to do with you is kind of scratch the surface of the very smallest bit of what is possible with Python. But Python is a very multi-purpose language. If you learn Python, you can really use it to do almost anything. So there are websites that are made with Pythons. Python can be used with databases, et cetera, et cetera. So just saying that, I wanted to say a little bit about what you could do with Python before we start this next section. So in this next section, what we're going to be doing with Python is we're going to be using it to read in information from a text file. And the text file that we're going to use is a PDB file, which for those of you who work in biology or bio-related areas, and you're probably familiar with PDB files. So a PDB file is something from the protein data bank, and it has information about protein structure. So it will have information about locations of the atoms, et cetera, in that PDB file. So we're going to be using Python to read in information from a PDB file and sort of process that information. So I'm just trying to look at how long I have for this lesson. All right. Okay, so if you're looking at if you were in your Jupyter Notebook, I want you to click back out to the tab that says IQB Get, because I'm going to be sort of starting from here. And then I want you to click on the file parsing lesson. So just go ahead and click there, and that will open the notebook for you. So at the top here, you'll recognize sort of how this notebook has been set up. If I double click on this cell, I'll see that it says file parsing. So that is a nice header for me that's been formatted in. We can see that it is in Markdown. And this section is going to answer the questions of how do I sort through information in a text file and extract particular pieces of information. And you can see some objectives and key points here. So I mentioned before that the file that we're going to be working with is from the protein data bank. So I'm going to show you, I'm actually just going to show you some of those files. I want to show you that you can look at text files in the Jupyter Notebook. So I'm going to, and you can just watch this part. You don't have to follow me. I'm just going to open the file for you. I'm going to click on PDB files. And then I'm just going to look at one of these PDB files. It doesn't really matter which one, but let's just get an idea of what these PDB files look like and maybe why we would maybe want to use programming for getting information from them. So if I look at this PDB file, I open it, I can see that this file is quite long. So I'm just kind of looking at it. Don't get too caught up on where I am in this file, just kind of get an idea of the file overall. So it gives us a little bit of information about this protein that we're looking at. It has some keywords here, say header, title, compound. There are some remarks. If I scroll down, scroll, I see some amino acids here, then some information about atoms. So this is a big file, and there's a lot of information in it. And if we want to get information, if we want to get particular pieces of information out of this file, it might be really beneficial to us to be able to program something to do that instead of us having to go in and read it ourselves, especially when we have a lot of files to work with. So what we're going to do in this section which I just clicked back over to my file parsing notebook, is that we are going to learn how we can use Python to extract some information from that file. And we're going to be using like keywords. So we saw a lot of keywords in that file. So we're going to be looking for particular keywords in a PDB file. So what I would like everyone to do at this point is I want everyone to go to there. You'll see that there's some information here and we don't really want that. So I want you to go to kernel. And then I want you to click restart and clear output and then confirm. So this is just making it so that we have a fresh Jupyter Notebook to work with. Sometimes you'll want to do that. If you've been working with your notebook and you want all of your executed code to go away because you kind of want to re-execute everything, that is something that you can do. So that was kernel and then restart and clear output. I'll do it one more time. So kernel, restart and clear output, and then I'll click that red button. All right, so in the last lesson, we covered several concepts that are really essential to programming. And these are concepts that aren't essential just to Python programming. They're really, really important for all programming languages. And that was setting variables, data types, we did for loops, and then we did logic statements. So we saw, those were 4 big concepts that we saw. Everything that we were using in the last session was built into Python automatically. So when we open Python, we have access to all that stuff that we use, like a for loop, an if statement, the word float, the word type, the word print. Sometimes in Python, well, not some, a lot of times in Python, you're going to want to use things that aren't sort of built into this base environment. So there's a lot more that you can do with Python. It's not all built in automatically, because if it was, it would make your environment really slow. So Python's solution to this is something called a Python library, which it will be using in subsequent sessions. And so these are collections of other functionality or functions that you can use. And if you want to use this stuff that's not just built in, you have to tell Python that you want to use it. And the way that we tell Python we want to use it is by using something called an import statement. And I'm highlighting this import statement. So the first Python library that we're going to be using in this workshop is one called OS. And OS is a library that is used with your, that gives you sort of functions related to your operating system. So that's what OS stands for, is operating system. And we're going to be using OS to see some information about the folders that we're in and the files that we have. And then we're going to be using OS to kind of tell the computer where the files that we want to read are. So OS is not something that's built into Python automatically. We have to import it. And if we want to import a library, we put the word import and then the library name, and the library that we want to use is OS. So that's what this first cell is. So you can click inside of this cell and then press Shift and Enter at the same time to execute it. This was pointed out in the chat, but I'll also point it out here. After you execute a cell, you'll notice a line, or not a line, a number appearing here. So that means that this cell has been executed. So there's a 1 here. That means the cell has been executed. And everyone should see no output from this cell. And what that means is that this executed, like this ran without any problems. So once you click Shift and Enter, a 1 should appear here. And you shouldn't see any output, and that means that everything is great. That means everything is working. This next function, what we're doing here is we're just kind of looking at the files that we have. So before we read in our file, we want to get some information about the files in our Jupyter Notebook. This is a function in the OS library called Get CWD, and that's for Get Current Working Directory. So that's going to tell me the name of the folder that I'm in. And if I want, I can put my cursor here at the beginning and then maybe hit the up arrow and write a note, show the folder I am in. So that is what this line of code is going to do. And this is really more useful if you are on your own personal computer. So for those of you who are using Anaconda, it may be more useful for you. For those of you on ChemCompute, one nice thing about being on ChemCompute is you don't have to worry as much about the folder that you're in. But when you say os.get CWD, it's going to show you the folder that you're in, and you'll notice this last part says IQB.get, and that was the name of your folder that all of our notebooks are in. So that is your home directory. So all we're doing right now is kind of establishing, our ultimate goal is to read data from a PDB file. What we're doing now is establishing where those PDB files are. Next, this is another function in the OS library, and I'm going to write a comment here about what this function does. This lists the files that are in your directory. So this is a function in the OS library called listdir, and it's for listing the files that are in a directory. So it's listdir and then open and close parentheses with nothing inside of the parentheses. And if you execute that cell by pressing Shift and Enter, you are going to see sort of a list of files. I'm not going to do this, but if you click out to your main Jupyter Notebook folder, if you look in that IQB.get directory, you'll see sort of the same, you'll see the same files there. So what I'm seeing is that I have a file called fileparsing.ipynb, a file called license. This PDB files is a directory or a folder, and that folder contains PDB files. So the folder is descriptive of what's in the file. And then you'll see our other notebooks here. So the next function that we're going to use is, it's still the listdir function, but it's a little bit different than last time. Now we have put the folder PDB files in quotes. And that, if I execute it, is going to show me a list of PDB files that I have. So if you click back out and look, it's going to match what you see here. So that is, I'm going to click here just to make sure I'm out on IQB.get. So this is just to demonstrate to you that you can use Python to kind of view what files you have. And what we're going to do is we are going to be reading one of these files and getting information from it. So now that we've figured out where the file is, we have to tell, in order to get information from the file using Python, we have to tell Python where the file is. And that's where this os.path, there is another function in the OS library called path join. And so we're going to use that function to tell Python where the file is. And that's doing something called creating a file path. And the way that you can think of a file path is, a file path is basically what you would tell if you were describing to one of your friends how to find a file on your computer. You might say to them, first, I want you to click the desktop folder. Then I want you to click the data folder. Then I want you to click the PDB. So each one of those directions, like desktop, data, PDB files, that's a path that you're telling them to click. So that is what the concept of a file path is telling the computer where a file is. So basically what path they have to follow to find a file. So we are going to, for this first part, we're going to work with this PDB file for EYR.pdb. And we already figured this out. We figured out that if we were telling someone how to find it, we would say from where you are right now, which is IQB.get, I want you to click on the PDB files folder, and then I want you to click on this file, and that is the file that I want you to read. So we are going to make a file path using a Python function. So I'm going to write a comment to myself, make a file path for Python. And so I'm going to create a variable called file path, and you could call this variable anything that you wanted. I'm just going to call it file path because I think that that's a descriptive name. And I think that later when I am like when I'm reading my code later, I think I'm going to understand what's in that variable. And to tell Python the path that it should click to find a file, we use a function called os.path.join. And then we hit parentheses. So that's going to create an open and close parentheses for us. And then in quotes, we are going to, well, then what we're going to do is we're going to type in quotes the path that they would have to type to find that file. So from where I am right now, I'm going to tell the computer to look for a folder called PDB files. So I'll type that in quotes. And then that is one step. I'm going to put a comma to tell it the next step. So after you click the PDB files folder, I want you to click on, and I said we were going to do for eyr.pdb. So here I've made a file path for Python. And what this is going to do, I can then look at the file path that I've made and I can print it. So I'm going to use my print function so I can see what is in that variable. And I'll just say print file path. And this is what it's going to construct. So this is what it made for us. So what this is file path is, we learned in the last lesson, a string, or it's something that's like a word. And you might think I could have just typed this myself, which maybe you could have, but this is also make sure that your code is interoperable, that it can run on sort of any operating system. So it's in the OS library. So this is what we've done. We've told Python that we're going to read a file, and if it wants to find the file, to look in the PDB files folder and then look for a file called for eyr.pdb. So that's just telling Python where the file is. Now we have to tell Python to take information out of the file. So we're like, once you find that file, I want you to take the information out of it and read it. And we want to store that in a variable so that we could do something with it. And this is the way that we open a file and read information from it in Python. So we can't really explain this better than this is just the syntax for it. This is the way Python understands to do it. But you're going to type the word with, and then a space, and then the word open, and then parentheses, and I'll type that again. So I'll do WITH, and then OPEN, and then parentheses, and then I'm going to put that file path I just built, and then I'm going to put the word as, and then I can put a variable. Usually you will see people just put F here with open file path as F. I'm seeing there's a lot of chat messages. I'm assuming being answered with open file path as F. And then you put a colon, and colons are very important in Python. You'll notice that then you press enter, you'll go to the next line. And then we're going to do, we want to tell Python to get all of the data out of that file. So I'll say data equals, and we're going to be using a function called read lines. So F represents the file that is open, and then we want to tell Python to get the information in that file and store it in a variable called data, and we are using a function called read lines. And read lines has a very specific behavior. So we're learning just one way to read information from a Python file. There are many ways to read information from a Python file, but the way that this particular function works is that it's going to give us a list, which we learned about lists in the last lesson, where every element of the list is a line from our file. So we'll look at what that means. So once I have this typed, I can press Shift Enter. And if I've done everything correctly, I should not see any output. Okay, so if you are able to execute this, can we do a status check? If you saw this without any output, can you use your green check mark, please? I do see questions in the chat about asking about Excel. So I want to address that. So if you want to read Excel files, it's actually something that we won't be covering today in our lesson. Python does have support for reading Excel files. For that, you would use a library called Pandas, which we do cover in our, this is a short version of our Python data and scripting workshop. We do cover Pandas in our longer workshop. For those of you who are familiar with R, Pandas has an object called a data frame, which models R's data frame, so it's very similar. Yes. So if you're looking to read Excel files, then Pandas is going to be what you will want to use. And Pandas is great. And we'll likely be holding some longer versions of this workshop. So for those of you who really want to learn Pandas, I would recommend coming to that workshop. Okay, so I see that we've got a lot of people with green check marks. I want to look at what is in this data variable. I want to show you what's in this data variable. So I'm going to insert a cell so that I can show you that. So let's go to insert and then insert cell below. I'll address I can tell. So we have a question in the chat about the difference between read and read lines. And I do, is one of the TAs addressing that, or should I answer it? I can answer.
Go ahead and answer it, Jessica.
All right. So for those of you who have used Python before and have used the read function instead of the read lines function, if you haven't used Python before and you haven't used read before, don't worry, don't listen to what I'm saying right now. Read puts everything in one big string. So it's one variable that comes out, it's one big string. Read lines puts everything into a list of strings where every element is a different line. So I'll show you that now. So I just put in a cell. So I went to insert and then cell below. And what I can do is I'm going to print. So I'm going to examine what data is. I'm going to print the type of data. And then, so I'm going to execute that first. And you'll see that when I say to print the type, it tells me that data is a list. And then I can also do something like, remember in the last lesson, we learned that if we have a list, we can use square brackets to get a particular element of the list. So if I want to see what that first line is, I can do data 0. That will give me the first line. So I'm going to print the first line. And you can see what our first line is. It's header, hydrolase inhibitor. And so that is the first, if we go back to that for EYR file and look at it, that's going to be the first thing on the first line. You could look at any line. So I could look at the second line, or I could put any number here to see, any line in my file. Which brings us to our check your understanding section. So what we want to do is check that your file was read incorrectly by determining how many lines are in the file. So let's spend 2 minutes here to see if we can figure that out. Oh, I think I'm way behind.
Time-wise?
Yeah.
That's all right. Do a careful job. Right.
Okay.
Our main goal is for people to get comfortable with Python.
Okay.
So
yep.
It's better.
So,
it's okay.
Okay. Thank you, Paul. All right, everyone. So work on this. Check your understanding. What we'd like for you to do is see if you can figure out how many lines are in the file. And for this, you might have to, you'll have to think back to a function that we learned in the last session for a way that you can figure out how many elements are in a list. Don't say the answer yet. We'll pause here for one more minute.
All right, if you're still trying to figure it out, don't look in the chat window.
Yeah. Maybe think on 30 more seconds, see if you can figure it out.
There's a question here, why not read this as a table? Well, that's something you could actually do in Pandas if you created a data frame. But for our purposes, I don't know, I don't have a deeper answer than that.
So
Charlie?
I'll have an answer for that. Yeah, or go ahead.
Well, it depends upon the file type. If it's a well-organized file type, then yeah, I'd read it as a table. If it's messier, you might have to kind of go in line by line and pick it apart, parse it apart pretty much manually, like this. So you have more power here, but if it's well organized, yeah, I would definitely do a table.
Right. So the thing about that will work well when you have the same number of columns always. This PDB file does not always, every line does not always have the same number of columns, and sometimes like different parts of the file are unrelated. So some parts are like coordinates, some parts are about like structure. So it doesn't lend itself to a table as well as say something more regular. So in this case, so there are many ways to parse a file in Python. You might choose, if you knew how to do that, to put this in a table, but this is a case where reading line by line might be something you want to do. Okay, so let's talk about this. So for this, check your understanding, we were supposed to check that our file was read incorrectly by determining how many lines were in the file. So we have to think here about what we know about what's in data, and then we have to think about what we learned in the last session. So we think about what is in data. We just saw here that this is a list. And in the last session, we also learned that if we want to find the number of elements in a list or how many things are in the list, we can use a function called len or length. So we have to think about the readlines function and the way the readlines function works. It reads everything into a list where each line is a different element of the list. So if we want to know the number of lines, we want to know how many elements are in the list, and we can find that out using the length function. So I can do something like num lines equals len, and then I'll put data. And then I could do a nice print statement. I could say something like there are, let's see, there are comma num lines. So this is just something that I'm doing to print it nicely for myself. And so I might do that. So I see that there are 2232 lines, 2,232 lines in the file. And if I wanted to verify that, I could go look at the file and count them, but I don't think that, I don't think we really want to do that. So this is how we can figure out how many lines are in the file. So now let's talk about how we can find a particular piece of information in our file. So let's say that we want to find the heterogens in our PDB file. We want to find information about those. In a PDB file, where that is indicated, and this is just a property of how PDB files work, those are indicated with the keyword HET in AM. So sort of the start of the line has that in it. So we can use what we learned in the last session, looping through elements in a list, and then using our logic statements to find that information in the file. So the first thing that we want to do is we want to go over each line in the file. And if we want to go over each line in the file, that sounds like something that we learned in our last lesson. And the thing that we learned that it sounds like is the for loop. So since this is in a list, we can use the for loop to go over the items in the list. So to use our for loop, I'll type the word for, and then I'm going to give a variable, I'll just call it line in data. And I just want to demonstrate in this cell what this for loop is doing. So I'm just going to, starting here, I'm just going to print line. And what should I expect to see here is that it will print each line in the file. So it's just going to show me something that looks a lot like the file that I read. So this is the whole file. Here it is. It's printed everything. It's printed 2,000 lines. So that's not that useful. So let's consider this for loop and figure out how we can find the information about the heterogens. So I'll do for line in data. And now I want to use some logic here. So I want to look for a particular piece of information. So instead of printing everything, I only want to print the line if it has what I'm looking for in it. So I'm going to type my if statement. So if, and then I'll type quotes, and I'll do HET-NAM. So that is the keyword that I'm looking for. And the way that I know that is I know things about PDB files, so you'd have to kind of figure that out if you're, working with the file, whatever file, you have to know what you're looking for in order to tell the computer what you're looking for. But I'm looking for this keyword, and this is very important that it's all in all caps. So this has to match exactly. If hetnam in line, I'm going to print the line. And we'll see how fast that works. And you'll also see the difference from what we just did. So now it only prints one line. So we went from printing all 2,000 lines to only printing one line. And we see some information about that. So it says, so this is the line. It says our keyword, and then it says RIT, and then I'm actually not 100% on the pronunciation, but this is the long name. So we have the keyword, we have an abbreviation, and then we have the longer name of that molecule. Okay, and so I think what I want to do is I actually want to pull out this this piece of information. I want to get the abbreviation. So I'm going to continue working with my code here. So if you were doing this, like on your own, I would recommend sort of developing into this same cell, like typing, like figuring out one thing, then typing the next thing. But so that you have a full record from this workshop, I am going to copy this code and paste it to keep working on it. So I want to pull out this abbreviation. And so I'm going to show you how to process this. So the first thing I want to do is, instead of printing the line, I want to save it in a variable so that I can keep working with it. Because printing is just going to show it to me, but then I can't do anything with it. So if I want to save it in a variable to do something later, I need to use that variable equals to save it. Okay, so I will save this. I'm going to create a new variable called hetnam line and set it equal to line. And that's just going to save that for me in something that like persists longer than this for loop. And then I want to kind of split up this line. So this is a new function that we're going to learn. And that is the split function. So I'm going to create a variable called words and set it equal to, and then I'm going to take that variable I just created And I'm going to put a dot, and then I'm going to call the split function. What the split function does is it's going to take a string. So what's going to be in this hetnam line is a string. And then I can split that string into different parts. And this is going to give me a new list. And this list, every word is going to be an element. So I'm going to print it so you can see what that looks like. So now I've printed words. So I have hetnam, writ, and then, so that's just that line split up into different parts. And one thing that you'll notice here is that words exist, like we created it inside of the for loop, and it still exists here outside of the for loop, and I can keep working with it. So if I want to pull out this abbreviation, I'm going to look at my list. I'm going to say that's index 0 and then index 1 for the abbreviation. So I'm going to create a variable called abbreviation and set it equal to words. And then 0, this is index 0, and this is index 1. So I'll set it equal to words index 1, and then I will print my abbreviation. So that is the basics of finding information in a file. I actually think that what we could do now, so let me get, I think that we can use this check your understanding as our hands-on exercise. Paul?
I agree, Jessica, that's good.
Okay, yes. So this is sort of the basics of how you would find information about sort of find information from a text file using Python. And as other people have said, well, there are different ways to read information in Python. For this file, this is a text file that we would call irregular. So it's like a lot of words and numbers, and there's not a set number of columns. So in this case, we think using something like the read lines function and looking for specific keywords is really useful. So now we're going to do our hands-on exercise for this section. And if you continue to read, there are some other exercises that you can complete. And then there was a question in the chat about how we could know what line a particular item occurred on. And oh, it's not actually in the notebook, but we will send in the later lesson materials information on how you can get the particular line number. That's something that you can definitely do. Okay, so we want to do our hands-on exercise now, and I think this is a really good hands-on exercise that's going to require you to apply many concepts that you have learned already. So what this says is some PDB files contain more than one heterogen. So for this file that we just did, we said if hetnam in line print line, and we printed one thing. There are some that will print multiple lines, so there's more than one. So for this portion, what we'd like for you to do is to read in the PDB file 1DDO and find the lines that have heterogens. So that's the first part. The second part is to figure out how you can save all of those in a list. So first part, you'll want to open the file, look for that keyword, and then pull out the abbreviation. And you can print that, but the sort of overall goal is to save all of those in a list. So we'll want to save those in a list. So see if you can, that is the hands-on exercise. Was that clear, or do I need to clarify? Does everyone feel like they know what I want on that problem? Yes, hetnam, that's what we're looking for. Okay, yes, okay, so What we just did in the last section is we read a file called 4yer.pdb, and we were looking for files that for lines in that file that had this keyword. So we're looking to figure out what the molecules are, what the heterogen molecules are. I think that's the word, but it's specified with the hetnam keyword. For the file that we read as an example, there's only one. However, PDB files can have multiple hetnam lines. And what we want you to do is to read the file called 1DDO and save all of those abbreviations, like save the hetnam lines in a new list. So basically figure out how many there are and save them in a list. Okay, great. I'm going to clear the reactions. We will work on this for 10 minutes, I think. And then we will go over the answer. And if you have it, you can use your green check mark. And then once we're closer, you can share. Once we're closer to the time point, you can kind of share, everyone can share their solutions. But wait a little bit before you do that. if anyone wants to, those of you who have completed the exercise, if you want to share what your answer was, not your code, like what your sort of what your list that you created looked like, maybe you could share that to the chat. Great, thanks everyone for sharing. I am liking the answers that I'm seeing. I am seeing that some of you appended the whole or have the whole line. Some of you do have the abbreviations. So if you had the whole line, see if you can figure out how to get just the abbreviations in a list. And someone asked how long this workshop is. We've got about a little less than 2 hours left in the workshop.
There's a question about the recording for the workshop. It's being recorded. I thought it wasn't, but it is. And we will have the list. You can keep access to ChemCompute now. The special spot that Mark Perry set up for us on ChemCompute, you may not be able to use that. In fact, you won't. I'll probably close down tomorrow, but you can use ChemCompute, and one of the tabs is called Jupyter. You just go under that tab and you can import the same directory and use it. I should say you're importing the same GitHub repository and use it. Now, if you want to keep the files you created today and use them tomorrow, I can't tell you how to save a copy of that locally. Jessica, can you?
Yes, we can go over it at the end.
Okay, good. Thank you. Seeing some very good answers here. I like somebody actually had their answer print out the heterogens, the list of heterogens, and then gives the list. So that's even more informative. And that's really important when you're writing code is to make it the output as informative and meaningful as possible.
All right, let's talk about this. So I see that we had a lot of people get this, so good job. Good job, everyone. And if you didn't quite make it, don't feel too bad about it. I think this was a tough exercise. Okay, so for this, we were going to read in a different PDB file, and we're going to get the information about that hetnam keyword. We wanted to save that in a list. So the file that we said we were reading was 1DDO. So to do this exercise, you pretty much have to kind of remember everything that we've done so far in the notebook and then do it again for this new file. So the first thing that we have to do is we have to open that file 1DDO. And we have to open it, we have to build a file path. We have to tell Python where it is. So if we didn't have the OS library imported already, we would import OS here. So I'm just going to import it again just to be safe. So I'm just going to import it here so everything is kind of self-contained in one cell. So I just typed import OS. The next thing I'm going to do is I'm going to create a file name, and I'm going to give this a different name than what I had before, just to make sure I know what I'm working with. And I'm going to call it DDO file. It's okay if in your solution you wrote something else, but I'll do os.path.join, and then I'll say PDB files. And then I will go outside of my quotes, put a comma, and then I'll type the name of that file, which was 1DDO.pdb. So I made my file path. So I'm telling Python where the file is. Now I have to open the file. And this is how I did that before. I did with open. And then I give the name of the file to open as F, with open DDO file as F. And I'm giving these new names just so that I know for sure what's in the variables, because if I called it the same thing, then like maybe I'm working with my notebook and I don't know if data is the other file or if data was this file. So I'll just call it something different. DDO data equals f dot read lines. And then I like writing my code in pieces. So I'm going to check and make sure that this works before I go any farther. So I'll press enter and enter again, and then I'm going to go outside of this with. So I'm going to hit the back button, and then I'm just going to print DDO data, and I'm just going to print the first line to make sure that it was read in correctly. And that looks good to me. I see this says 1 DDO, that looks right. So I always find it really useful when I am writing code to write it in pieces. So now I'll do looping over the file. So I'll do for line in DDO data. And then I'm going to look for that keyword if petnam in line. And then to start out, I am just going to print the line. So now I see that there are 3. And I'm going to do the same thing that I did before. So this is kind of the same problem that we did before. So I am going to create, I can do a variable here. Well, I'll do create that variable. Then I'm going to split it into words. And then I'm just going to, well, actually, I'll keep going. I think that this is going to be the same. Well, I'll print words. Okay, so then I have, what's happening is it's printing 3 lists. I want to get my abbreviation. And we said that was words 1. And then I can print that abbreviation. So let me get rid of this other print statement. I'm just going to comment it out. So now I can see that I have printed the abbreviations. So right now I'm really close to what I wanted for the solution. However, there is one final thing that we wanted to do, and that was to save everything in a list. And so to save each of these, to save these in a list, we're going to have to think back to something that we did in the first lesson, and that was appending to a list. So we're going to use that sort of pattern of creating an empty list and appending to it. And this is something that you'll see, often in Python. If you program, you'll see like certain patterns of things that people do. This is one of them. So if I want to parse through something in a for loop, then it's really common to create a list, an empty list, and append to it. So I will make a list called, I'm just going to name it petnams, and then set it equal to open and close square brackets. So that creates an empty list. And then after I print that abbreviation, I'm going to append it. So I'll do petnams.append. And then I'm going to put in parentheses what I want to append, and I want to append ABBREV. So I've done all this typing, and I want to make sure to execute it. So I still see this printed, and now I can do print petnams. And I will see my list.
Jessica, we have a question. Can you clear variables that you know you're not going to reuse without clearing everything using the kernel option?
There are ways in Python to get rid of variables that you don't want anymore. They're not really used usually. So for all our purposes, no. You can just clear all of them by doing kernel restart. But this is a really good question and makes a good point. And that is that sometimes in the Jupyter Notebook, because of the way it lets you execute cells in different orders, you may not know what is in a variable. So it's good to use like different variable names. And I did want to show you this because I can't remember who it was, but someone had like the same thing appended several times to a list. That's something that can happen sometimes in Jupyter Notebooks. So for example, if I had this in a different cell and wasn't creating it every time I ran this code, it would just keep appending to this list and this list would get longer and longer. So one thing that is good to do, and it's just what someone said, is if you're getting kind of a weird output in your Jupyter Notebook, you can go to kernel, and I like to do restart and clear output, and then go to just the part that you need to run if you want to make sure you know for sure. So that's one reason I put import OS here. And then if I execute that and then execute this, then I'm going to get exactly what I want without those previous code cells affecting what I see. So that can be nice. And it does take like working with the Jupyter Notebook takes practice. So things might seem a little strange at first in it because of the way it lets you execute things in different orders, but it is something that you get used to eventually. Okay, so that is file parsing, and I'll pause here. Are there any questions that weren't addressed?
Okay, somebody's asking for the correct code in the chat, Jessica. Okay.
Yes.
Great.
I will send, so 2 different cells, so it's going to be 2 messages. Here's the first one. And then here is the second one.
And there's a question about what does import OS do again? Import OS, Iman, brings in the library, the OS library, which does operating system things.
Right.
Right.
Yes, so Python is a very powerful programming language. It can do a lot of different things. When you just open a Jupyter Notebook, you're going to have some built-in functions for Python, but it doesn't bring in everything that Python can do at one time, because then it would be a lot of stuff. It would take up a lot of memory on your computer. So we import libraries. For a lot of times, you're going to import libraries as you want to use them. And libraries are just collections of functions that do things that other people have written. Okay, and with that, I'm going to turn it back over to Paul.
All right. We've been staring at our monitors for 2.5 hours. So let's take a 10-minute break. We'll come back in 10 minutes and do our next lesson is about working with multiple files. All right. So, and I encourage you, if you can not, I encourage you not to be reading email. Get away from the monitor. Let your eyes rest. Walk around a little bit. We'll be back in 10 minutes.